Welcome to lectures on functions of a real variable. This is the fourth lecture in this series. The title is Types and Inverse of a Function. I am your lecturer, Professor E.O. Efanga. Injective function. A function f from a to b is called a one-to-one or injective function if for every pair of element x1, x2 of a, x1 not equal to x2 implies that f of x1 is not equal to f of x2. That is, different elements in A have different images in B. This is the illustration. This is set A of element A, B, C, D, while this is set B of element 1, 2, 3, 4, and 5. Observe that different elements in A have different images in B. Example 1. Show that the function f from the set R of real numbers to the set R of real numbers given by f of x equal to 2x plus 5 is a one-to-one function. Solution. Let us pick two elements from the domain R. Let these two elements be x equal to 2 and x equal to 5. Then the images of these two elements are: the image of x equal to 2 is f of 2 equal to 2 times 2 plus 5, and that will give us 9. The image of 5 is f of 5, which is equal to 2 times 5 plus 5, and that will give us 15. Clearly, 2 is not equal to 5. Implies that f of 2 is not equal to f of 5. Hence, the function f is an injective function. Example 2. Show that a function f from the set R of real numbers to the set R of real numbers defined by f of x equal to x squared is not a one-to-one function. Solution. Let us select two different elements from the domain R, and let this element be x equals to minus 3 and x equals to 3. Then the image of x equals to minus 3 under the function f is f of minus 3 equal to minus 3 to the power 2, and that is equal to 9. While the image of x equals to 3 is f of 3, which is equal to 3 squared, and that is also equal to 9. Clearly, we have seen here that minus 3 is not equal to 3, but f of minus 3 is equal to f of 3. This shows that the function f is not a one-to-one function. Surjective function. The function f from a to b is called an onto or a surjective function if every element in B has an element in A assigned to it. That is, if the range of the function f coincides with the codomain B, then the function f is an onto function. This is an illustration of a surjective function. A set A of element A, B, C, D, and E, while this is the set B of element 1, 2, 3, 4. You can see that every element in A is mapped to element in B. The range of these functions is a set containing 1, 2, 3, 4, and that also coincides with the codomain B. Example 3. Let A be the set of elements -1, -2, -3, -4, 0, 1, 2, 3, and 4. And B be the set of elements -1, 0, 3, 8, and 15. Show that the function f from A to B given by f of x equal to x squared minus 1 is a surjective function. Solution. Let us find the images of every element in A under the function f. The image of -1 is f of -1, and that is equal to -1 squared minus 1. And that gives us 1 minus 1, which is equal to 0. The image of -2 is -2 squared minus 1, and that will give us 3. The image of -3 is -3 squared minus 1, and that will give us 8. The image of -4 is -4 squared minus 1, and that is 15. The image of 0 is 0 squared minus 1, and that will give us -1. The image of 1 is 1 squared minus 1, that is 0. The image of 2 is 2 squared minus 1, which is equal to 3. The image of 3 is 3 squared minus 1, which is equal to 8. And the image of 4 is 4 squared minus 1, which is equal to 16. Let us now form the range of this function. That's the set of all images. The range of f is equal to the set of -1, 0, 3, 8, and 15. Clearly, this is the same set as the codomain B. Hence, the function f is an onto function. Example 4. Let A be the set of elements -2, -1, 0, 1, and 2. And B be the set of elements 0, 1, 4, and 6. Show that the function f from A to B given by f of x equal to x squared is not an onto function. Solution. The image of -2 under our function f is f of -2, and that is -2 squared, which is 4. The image of -1 is f of -1, that is -1 squared, 1. The image of 0 is f of 0, 0 squared is 0. The image of 1 is f of 1, 1 squared is 1. And the image of 2 is 2 squared, and that is equal to 4. Therefore, the range of f is the set of all these images. That is equal to the set of elements 0, 1, and 4. Clearly, this set is not equal to the codomain B. Look at the element in the codomain 0, 1, 4, and 6. So the range is a subset of the codomain. Hence, the function f is not an onto function. Bijective function. The function f from A to B is called a bijective function if it is both injective and surjective. This is an illustration of a bijective function. Observe that every element in the set A is mapped to element in the set B, and the range coincide with the codomain. Hence the function is both one-to-one and it is also onto. Example 5. Let A be the set of elements 0, 1, 2, 3, 4 and B the set of elements -1, 0, 3, 8 and 15. Show that the function f from A to B given by f of x equal to x squared minus 1 is a bijective function. Solution. Let us find the images of the element of A under f. F of 0 is equal to 0 squared minus 1, that is minus 1. F of 1 is 1 squared minus 1, and that will give us 0. F of 2 is 2 squared minus 1, that is 3. F of 3 is 3 squared minus 1, which gives us 8. And f of 4 is 4 squared minus 1, and that is equal to 15. Therefore, the range of f is the set of all these images, which consists of the element -1, 0, 3, 8, and 15. Clearly, this set is the same thing as the codomain B. And also, all the elements have different images. Hence, the function is one-to-one and it is onto. So, therefore, the function f is a bijective function. On your own, say whether the following functions is injective, surjective, or bijective. 1. The function f from the set of natural number n to the set of natural number n given by f of x equal to 6x plus 2. 2. The function f from z to q given by f of x equal to x squared, where z is a set of integers and q is a set of rational numbers. 3. The function f from z to z given by f of x equal to x, where z is a set of integers. 4. The function f from c to r given by f of x plus iy is equal to the square root of x squared plus y squared, where c is the set of complex numbers and r is the set of real numbers. Inverse of a function. The inverse of the function f from A to B is a relation from B to A, written as this. We note that 1. The inverse of f is not equal to 1 all over f. And 2. F inverse is not necessarily a function. However, f inverse will be a function if f is a bijective function. To find the inverse of the function y equal to f of x, we simply solve for x in the equation y equal to f of x to obtain x equal to f inverse of y. Example 6. Let f from A to B be a function given by f of x equal to x squared, where A is a set of elements -2, -1, 0, 1, and 2, and B is a set of elements 0, 1, 4, and 6. Find the inverse of f from B to A and show that it is not a function. Solution. Let y equal to x squared, then x is equal to plus or minus the square root of y. That is, f inverse of y is equal to plus or minus the square root of y for all y in the codomain B. This is not a function because the element 1 in B has two images, -1 and 1 in A. The element 4 in B has two images, -2 and 2 in A. Also, the element 6 in B has no image in A. Example 7. Let f from R to R be a function given by f of x equals to 3x minus 4. Find the inverse of the function. Solution. We let y equals to 3x minus 4 and then solve for x. 3x equals to y plus 4. Dividing both sides by 3, we obtain x equals to y plus 4 all over 3. So therefore, f inverse of y is equal to y plus 4 all over 3. This f inverse of y is a function because for every real number y plus 4 all over 3 is unique. Example 8. Let f from R to R be a function given by f of x equals to 3x squared minus 4. Find the inverse of the function. Solution. Let y equals to 3x squared minus 4. Then 3x squared is equal to y plus 4. Dividing both sides by 3, we obtain x squared equals to y plus 4 all over 3. And taking square root of both sides, that gives us x equals to plus or minus square root of y plus 4 all over 3. Therefore, f inverse of y is equal to plus or minus the square root of y plus 4 all over 3. Equivalently, we can replace the variable y by x to obtain f inverse of x equal to plus or minus square root of x plus 4 all over 3. We can see it here that f inverse of x is not a function because for each x there are two different values of f inverse of x, plus or minus. Example 9. Find the inverse of the function f from R plus to R given by f of x equal to x squared minus 3. Please note R plus is the set of positive real numbers, while R is the set of all real numbers. Show that f inverse from R to R plus is not a function. Solution. Let y equals to x squared minus 3. Then x squared is equal to y plus 3. Taking square root, we obtain x is equal to plus or minus square root of y plus 3. But x is positive, so x is equal to square root of y plus 3. Thus the negative component of this is dropped. Therefore, f inverse of y is equal to square root of y plus 3. This is not a function because all y less than minus 3 has no images in R plus. For instance, when y is minus 3, x will be equal to square root of minus 3 plus 3, that's square root of 0. and square root of 0 is 0. 0 is not a positive real number. When x is minus 4, what you have here will be minus 4 plus 3, which is minus 1. And square root of minus 1 is an imaginary unit. Example 10. Let A be a set of non-negative real numbers and B be the set of all y such that y is greater than or equals to minus 3. Find the inverse of the function f from A to B given by f of x equal to x squared minus 3. Show that f inverse from B to A is a function. Solution. Let y equals to x squared minus 3. Then x squared is equal to y plus 3. Taking square root of both sides, we obtain x equal to plus or minus the square root of y plus 3. But x is greater than or equal to 0, since A is a set of non-negative real numbers, so x is greater than or equal to 0. So we have to drop the negative part of this x to obtain x equal to the square root of y plus 3. Therefore, f inverse of y is equal to the square root of y plus 3. For all y greater than or equal to 3 is a function. For instance, when y is equal to minus 3, square root of minus 3 plus 3, that's square root of 0 is 0. And 0 is a non-negative real number. When y is equal to minus 2, we have square root of 3 minus 2, that's square root of 1, which is 1. 1 is also a non-negative real number, and so on. So f inverse of y, defined by square root of y plus 3, is actually a function from B to A. On your own, let f from the set of real numbers R to the set of real numbers R be a function given by f of x. Find the inverse of f of x. Which inverse is a function? 1. F of x is equal to 5x squared minus 3x plus 2. 2. F of x is equal to 1 all over 2x plus 1. 3. F of x is equal to square root of 6x plus 10. And 4. F of x is equal to 6x minus 3 all over x plus 5. This is the end of our lecture. Thank you for watching, and keep on watching.